So, by the way, some neat operators allow you to append to the string. For example, this plus equal. You can append other strings, individual characters, or C strings. It's basically say, oh, I have my string, so I want to add this at the end of it. So it's appending. But similar to assignment, you can append fragments of other strings. You can append to your strings, similar to we were trying to assign very similar stuff, but you can say, I want to append 6 characters A at the end, or 6,000 of them. It's, you know, it's all available, right? So, and then you can append individual, and this is not even covering all versions of append that are available. You can find in the documentation, you can find other versions. So there is quite rich functionality for appending. Access to individual characters, like we already tried, when you have a string, you can then go and access individual characters using square bracket notation. The square bracket notation here, we will go back to the discussion of square bracket index style access to our classes when we cover overloaded operators. We'll find out how we can design our own class where we can provide square bracket access to elements inside of our class. So, but right now, just hopefully this is all you know, kind of usable. So if I say string hello, I construct a string, and then I'm replacing the first character with uppercase J, then I get Jello as a result. So there is also @member function, which works almost exactly the same way as this. So the only difference is that the @member function of the string, if this index is out of range, that this character doesn't exist, it's like too far out there, then @version will check for will check for the non-existing position and will throw an exception. So the @version, by the way, in other high-level programming language, for example, in Visual Basic, when you work with strings, pretty much the same approach. The function there will generate an error, throw an exception. In C++, the behavior of square brackets is doing the same as the C programming language does. There's no checks. Your program will crash if this is not a good index. The function provides you a way to detect the error. First of all, the exception will be generated, but there is a way to catch that exception and then handle it as special condition, special case, and not let program to crash. So for now, we're not going to go too deep into this possibility, but when we cover exceptions, when we talk about C++ exceptions, we may as well try this and see if we can make this you know, more practical example. Again, when we talk about the operators and operator overloading, we will discuss this dual operator index behavior inside of C++ classes. I insert this slide here for completeness, that if you have to review this, it will be here. But the detail will be covered later on, the detailed coverage when we talk about operator overloading. So simple checks on our strings is that create a string. find out what the length is. Length and size do exactly the same thing. It's your choice which one to call. Just historically, the length was added before. Historically, what happened here was that the string is a container of characters, right? Is a dynamic container of characters. The string was historically designed before other containers were designed. When other containers were added to the C++ standard library, then that part of the library was using the size member function, but the string was using length. And eventually, the string header defined size and both size and length, just so that people are not confused. If you're more used to using size, as other C++ containers do, then you can use that. Otherwise, length is available because it was historically added there first, and length is an older name than size in the end. There's also a check for empty, same as size equals 0 check. All right, conversion to a character. Sometimes you could run into a situation where, for example, I have a function foo void function foo that takes a pointer to a character. I will say pointer to a character. So this is like C-string, an older function, and it wants to do something with this. All right, something silly. Cout print C-string. Right, just print it. But the whole thing is that this function is not expecting a string class. It's like older function that takes a pointer to a sequence of characters, the C-style string, such as this, right? So if I say someplace here foo, you know, and call it with hello, that's good. That's, you know, this function is happy. However, if I say foo and pass string 1, let's see if that works. If I try to build this, what happens is that the compiler gets unhappy, and what it does, it prints this error message that says, double click the error, points us to this line, and says, cannot convert parameter 1, right here, from standard string to character pointer. Right? So it just doesn't know how to convert string to character pointer. However, we know that, come on, this is a C string and we have a string class. There is a string there inside. Somehow, please, we need to solve this problem. So for that reason, it's basically an annoyance. But to overcome this annoyance, there is a member function named C-string. And this little function extracts C-string from string 1. Let's try this. Still an error. It says cannot convert parameter 1, which is now this, from constant character pointer to a character pointer. Now, again, this const versus non-const kicks in. If we look at the documentation for C-star thing, right here, it says that this function get C-string equivalent from the string object. It says it returns a pointer to an array that contains null terminated sequence of characters, very similar to what C-string is, representing the current value. So this array includes the same sequence of characters, blah blah blah, and it says, I don't know if it mentioned it somewhere here, but I cannot parse this documentation quick enough. What I'm just going to do here is that I'm going to say that what C* returns is a const string, the string that cannot be used for modifications. So our full function better use the constant version of pointer rather than non-constant. Let me save this fragment and comment on this a little bit.